Hi gang, normally we'd be in the lab, you would have wired up a Zen programmable relay by now, and you'd be in programming it. But sadly that's not the case this year, so I thought I'd do a quick video on a couple of points, just to make them a little clearer. I'll talk about examine if open and examine if closed, XIC and XIO, and I'll also talk about the three main parts or bits, status bits of timers. So the first thing I'm going to do is I'm going to come in here into the soft wiring, and I'll program a quick start stop station. So I'll add some contacts. I'll label them as I go. Over here, instead of an output relay coil, what I'll use is I'll use an internal relay or a memory location. And I'll call that my run bit. And then I'll use that output coil to latch my circuit on, so that now when the stop is closed at I0 and somebody presses I1, the start button, then current will get through line 0, energize M0 coil, which will pull in M0 contact, and as long as the stop button stays closed, this run will stay true and keep running. And this is where we can get into it. Now I'm going to go into the simulator, pull that over here. And you can see that I0 is right now is open. So let's change that to a closed contact, just the way that a stop button would be wired. Now with computers and PLCs in particular, they get into this thing examine if open, examine if closed. It looks to see if something is true or not. So in order for current to get through here, through I0, this contact, I0 must be closed, and once it's closed, then current can get through, and you can see here it's a green condition, which means it's good to go. If I was to press I1, you could see that it would turn green, and that would make that closed, which would then make that a true condition. So these are examine if closed conditions. Since a stop button is wired to the PLC as a closed button, it is an examine if closed command in the programming. So if I should open it up, that becomes false, and that would no longer allow current to get through that rung. And that's a safety feature in case wire should fall off the button, then the whole circuit will fail in a safe manner, and it'll fail in the off condition. It didn't latch on because I didn't press play, I didn't execute the scan cycle. So once I get the PLC executing the scan cycle, it's now going through left to right, top to bottom, and it'll look for the start button, and now you'll see that this coil energizes, it latches, giving me a latching circuit. So I hope that helps a little bit with examine with open and examine with closed. Let's go back into the programming screen, and now I can take a look at timers. Timers have three parts or bits, status bits to them. They have the enable bit, the timing bit, and the done bit. And hopefully this will make a bit more sense here in a minute. So as long as my circuit is running, I'm going to energize this M coil, and I'll also have that same action, enable the timer. So here I've got a timer enable. I'll even call it EN for enable, and I'll tie this on. When I click on the timer, you can see that I can't access any of the functions for the timer, because all I'm doing right now is enabling the timer to do its timing action, whatever that action is, or where the action is done. So now I can actually come over here. I'll take my timer bit, my second timer bit, and this particular bit, it gets a little confusing. It is both the timing bit as well as the done bit. So here I can select the type of timer I want. I can do an on delay, off delay, a one shot, which means it only happens once per setting. or I can have it flash back and forth as something else, and I can also have a twin timer where I can have multiple settings, on time and off time. To be more effective at this moment, let's just pick a flashing pulse. Now you can see it's set for seconds, milliseconds, so that would be 10 milliseconds, probably too short. Let's bump that up to 500 milliseconds, 50 times 10, 500, and that'll give us a half a second pulse. So this here, this T0, maybe I should just get rid of this. Let's just call this a flasher, make it less confusing. This timer up here in the green, the coil, well, that's my enable status bit, EN. That's where I'm enabling the timer, or giving the timer power to do its work. Here is where the action is being done. Or the DN. So this is where the action will actually place. As long as I'm enabling my timer on line 1, then my done bit, my action bit, if you wish, is going to do its action. And then I can make a light, and I'll pick an output, and I'll call this flashing light. This will enable the timer. The action will be done here and actually make the light flash. And then inside the timer, inside the PLC itself, you can see down here where it says set value. This is the actual timing bit where it does its counting. And that's a separate memory location within the PLC. So let's take a look at this at work. Let's take a look. We'll go into the simulator. We'll press play. My stop is closed, so that is a green condition. When I press the start button, I latch on my M0, which also continuously gives me power to my timer enable. And then here my timing action is being done, which actually makes my little light Q0 flash. And again, the timer timing bit, which we call TT, is actually here, and you can sort of see it counting down here. Now it's only a half a second, so it's going through quite quickly. Now the great part about PLCs and programming and all that good stuff is it's extremely easy to change things. So let's change this to 5.5 seconds, and we'll do an on delay now instead. Let's call it on delay, so we know it's different. And now when we look at it, we'll be able to watch the timing bit, the TT bit, which is just a memory location down here at the set value down at the bottom of the screen. You can see it's now set to 5 seconds, 500 milliseconds, and the preset value is down here. We'll enable the scan cycle, we'll start the program, and if you watch down here at the bottom of the screen, you can actually see the timer clicking up. And when it gets to 5.5 seconds, the light turns on. So this has been enabled. Once I press here, I'll stop it. This hasn't fully been enabled because the timing bit is doing its business. And once the timing bit is done doing its business, then the done bit will actually engage for the on delay. If I want to do an off delay, it's pretty simple. I'll just go in and change the parameters. And I'll maybe do 7 seconds, 7.5 seconds for a change, just so it's different. So back into the simulator, enable the scan cycle so the PLC is constantly reading the inputs, updating the memory locations, updating the outputs, and repeating the cycle over and over and over again. We'll press start. Oh, sorry, didn't enable the scan cycle. We'll press start. And you can see as soon as I press start, This is enabled this timer, but it's an off delay. So it'll delay turning itself off once I press stop. So once I press stop, you can see that the preset value, the timing bit, is counting up. And once it gets to 7 seconds, you'll see the timer turns off. So there you go. Examine if open. Actually here we only did the examine if closed command. We also looked at the enable bit, where we enable a timer by putting power to the coil of the timer. We've looked at the other status bit, which is the done bit, where the the contact actually does its action. And then down here we could watch in the preset value the timing bit, timer timing bit, the TT, as it goes through its accumulated value. So there you go. Your 3 status bits and examine if closed command.